Ford's affordable car put the world on wheels and made mobility accessible to everyone. To him, mobility meant freedom. Freedom to choose where to live, where to work, and to play. That freedom to move literally changed the human experience and elevated the quality of life. At Ford, mobility is and always has been so much more than just getting from point A to point B. It's about progress, human progress, thinking far beyond the vehicle. Today, we're still driven by this innovative mindset, one that pushes us to challenge traditional ways of thinking, of working, of moving. It sparks our imagination, lets us cultivate fresh ideas and new approaches to find transportation solutions for a constantly changing world, a world that's constantly challenged by this change. This mindset is also the beacon that guides us as we transform from a traditional vehicle manufacturer into a true mobility company that offers not only bold products, but exceptional consumer experiences too. It's smart vehicles for a smart world to move people safely, confidently, and freely. But Ford is more than just steel and lines of code. Ford is powered by our people. Because as diverse as our products and customers, so is our company. We not only celebrate diversity, we embrace it because it makes us a better, a stronger, and a more robust company. Ford is driven by our culture and a set of simple truths that guide us, teach us, and remind us every day of our purpose: to take the wheel and be empowered to ask questions, to challenge customs, to never be afraid to take an intelligent risk, and to make a real difference. And like it's always been at Ford, it's working together from every corner of the globe to build great products, to craft remarkable solutions, to give back to the communities we serve, and to collectively achieve something really meaningful. It's making people's lives better. And once again, changing the way the world moves.
Hey guys, thanks for responding to my text so quickly. Follow me. So I've got something really cool for you guys to take.
Whoa! Oh,
This is really cool.
it really is. Ford Mustang GT500. Awesome, man. I mean, perfect for the code behind cars, right?
Yeah.
Just the engine control alone, 1.5 million lines of code compiled into a 8 meg flash on an Infineon tri-core, 300 megahertz. Perfect for all the features in this. Thanks, Hal.
Hey, I'm glad you guys are excited. So what are you going to talk about at this conference?
Yeah, we're talking about how GitHub has helped us step up our software engineering game and setting us up for the future of how the world moves.
Awesome. Get the word out there. Be safe, have fun, have a good trip.
All right.
Thanks.
All right, Tim. Tim, is this the right place? Are we in the right?
Yeah, I think so.
All right, we're in the right place. Okay, cool. All right, we're finally at GitHub Universe, Tim.
Yeah, hey, so what kind of engine that thing have in it?
Oh, that's right. I didn't let you drive. It's a 5.2 liter V8 supercharged, 760 horsepower with a 7-speed dual clutch transmission.
So, not really that interesting.
Well, you have to drive it, Tim. So hello, everybody. I'm Tom Erickson from the powertrain division of Ford Motor Company, and I'm here to talk about software.
And my name's Tim Carmean, and I'm from the Electrical and Electronics Division.
So today we're going to talk, I'm going to cover the story of our software and powertrain.
And I'm going to talk about our what it took to get GitHub Enterprise into Ford Motor Company, and some of the DevOps stuff we've been working on with powertrain.
So I started at Ford in 1991, and I didn't realize that was a pivotal time in software development at Ford Motor Company. We didn't really use the term software engineer. We call them strategists. But software was a big part of our control systems. So when I first started, I was working on one of the first generations of electronic engine control systems, our EEC4. It was our fourth generation of software of systems, but we focused a lot more on the controls. And we developed a custom microprocessor, 8061 with Intel, so it's based on the 8086 architecture. Now, a lot of this, why did we need electronic engine control? Well, emissions was continually getting more and more challenging, and so we needed to improve the performance of the system and eliminate some of the mechanical wear that came from normal mechanical systems. So all the source code was really assembly language. We had some custom opcode that was responsible for the new 8061. Our software architecture might look a little simple. Back then, it was a single loop with interrupts based on the ignition firing order. So 1423 is the firing order of a four-cylinder engine. So the 8061 didn't include an on-chip memory at that point in time. So when I first started, the chip on the upper left, the 32K UV EEPROM, was my friend. We would develop with that. The one below it in the center is the actual production chip. That is the E2 PROM. It did allow us to reprogram, at least back then. Eventually, we evolved and got more and more memory. So memory became a big part of our lives. All of our code would just package into this small, tiny memory. So we have sector maps created for the assembly code, and then the calibration data was separate on purpose. We would build our code, embed it, and then we could modify the calibration data on the fly in the dynamometer or in the vehicle. So that was a big part. We had custom tools developed to really capture the calibration data itself. So at Ford in the 70s and 80s, our data processing group, which later became IT, really was embedded with digital at that time. We grabbed some of their servers and started to develop our own tools to support software. So you can see that we had to develop a custom cross-assembler for that new opcode. We also had to do some change management tools, since there really wasn't a lot of change management tools in the market at that time. And then data management, that special calibration data was really required. So we had a whole bunch of custom tools. All the code was managed in a CMS tool from digital, which maybe you guys have heard about that, maybe not. And then we had developed our own custom ASICs. So those were important. Application-specific ICs were just a big part of the control system itself. So evolution always happens in electronics, and in the 90s, we really started to be a part of the ongoing telecom industry as chipsets started to really embed more. So we had an opportunity to upgrade the 8061 to what we called an 8065, and then we included a lot of those custom ASICs in the chip. But we still didn't have on-chip memory, and we still had assembler code, and we called this our fifth generation. And this was the actual model that fully eliminated carburetors globally. Prior to that, the EEC4 was a US base, and so we extended out. In fact, in 91, when I first started, that's when I was a part of the international powertrain programs, where we were implementing some of these control systems for other markets like South America and Europe, and successfully eliminated carburetors. So assembly code, not necessarily most effective for us, and we wanted to expand and leverage some of the newer capabilities. So C code was a pretty natural migration for us. In 1992, Atria launched Rational Clearcase. And so by 94, we had that running in our own systems at Ford. And that really gave us a little chance to share our code a little more, control the labeling of the code, and so forth. But really, we still needed to evolve. PowerPC, the RISC-based processors were new, and we wanted to get on board with that. So our architecture changed. We do all the software in-house, so we developed our own real-time operating system that allowed us to create feature code that now expanded the content well beyond the 100 or so features we were doing at that time. All the driver code for all the hardware interfaces and other ASICs were also embedded there, and we had more loops that we could leverage. So all the feature engineers could actually start to leverage those individual loop times for whatever was important for their control systems. Now, we were already global. Ford's been actually global since the beginning of the company in the 1903. So we were already global, but our feature set was growing beyond 200. So we really had to start multi-siting our Clearcase all over the country, all over the world. And so my team had servers in Australia, Brazil, and Europe. And Clearcase really started to have a lot of admin overhead now. I had custom tools, custom scripts, multi-sided code everywhere. It was a very big challenge. And at the same time, every other system in the vehicle started really developing their own digital control systems or interfaces. So as those teams started up, they would choose other tools. So we had little enclaves of different tool sets throughout the company. So that really drove us to get some sort of commonality. You know, the powertrain was already pretty agile. We were running, even in the 90s, we could build software on a weekly basis. All those other teams were working with supplier partners. And so oftentimes, it would be a 3-month turnaround, or old waterfall models where the things would take forever to come out. And so our vehicle teams were really super frustrated with, you know, powertrains there all the time, and then the body module or restraints module, I got to wait 3 months. So that was a big challenge for us. So what are our key challenges? We have a big legacy in our powertrain systems that are very parochial. I run my own data center right now. I have a number of servers that are really kind of limited, and therefore I can't scale this for all those other teams that need infrastructure and tools. That old data center, I just got a message overnight that it was overtemping, so I need to get out of that. We need standard methods across all of our software community, and our vehicles are starting to get platforms that can distribute our features across the whole network. So a full network in the vehicle is our future. So development tool stack is really needed that can be integrated and leveraged. So.
And this is where I step in.
All right. He stepped in a long time ago.
So in 2014, I was working in our research and advanced infotainment department. And at that time, our mission was to develop prototype software to provide new infotainment experiences to our customers. To support this effort, we kind of needed a newer, modern tool chain that would support like a fail fast and ship often sort of mentality. And having an open source background from college, I gravitated towards the tool set in that space. So Git was obviously at the center of that. Part of this newer effort was to be partnering with universities and other like non-traditional suppliers in the automotive space. So I took a note from my buddy Gotham. He teaches at Michigan Tech University, and part of his coursework, he teaches how to use Git and how to use GitHub. And that's how his students turn in homework. So if you're not version controlling your stuff in Git and you're not submitting a pull request in GitHub, you're not getting full credit on your assignment. And so what this means is that, you know, this is one example of many where students are learning these newer modern tools in university. And Tom's going to talk a little bit more about why that's important a little later. So after a short tools comparison, we landed on GitHub Enterprise. And our purchasing folks negotiated a deal where we could get a small price break if we bought 250 seats instead of the 100 that we were planning for. And so with some help from some friends in IT, we managed to get GitHub Enterprise up and running in a few hours once all the license details were worked out.
And I didn't even know what Git was at that point.
So it took about a month for word of mouth to spread that somebody was running an instance of GitHub in the company. So since I had 150 extra seats, I kind of instituted a policy. If you want to come and kick the tires on this thing, I've got extra seats, but you got to understand the ground rules, right? This thing's in a lab. It's not backed up, right? And there's no uptime guarantee or anything like that. And I made people promise, like, hey, you can't put production code in here. Obviously, you can see where this is going. Of course they put production code in there.
Yeah.
So what I didn't realize as I was handing out these seats to people that I didn't know inside of the company, the people that I was handing these out to were the engineers in our IT department that were architecting our next generation data center. By this time we're in like 2015. GitHub hadn't officially launched yet, and it was already a critical piece of infrastructure in the company. And I think one of the coolest examples I've learned from those guys that were architecting the next-gen data center is how they manage the load balancer. So it's it's a modern load balancer. It's got a web interface and everything like that that they can use to configure it, but they lock that interface into read-only. If you want to make a change on the load balancer, you have to open up a pull request to the repo, and that fires off a webhook, which kicks off a full CI/CD pipeline that goes through all the CI checks. And if everything passes, it actually merges the pull request and deploys the code to the load balancer. I think that's pretty cool from a Ford perspective.
Who knew, right?
Yeah, true software-defined infrastructure. So in the summer of 2016, we launched GitHub Enterprise to about 500 devs.
So by 2017, our infotainment teams were really going strong. Delivery became more and more challenging. So we really needed to develop something new. And so a task force was put together. Tim and I and a number of other team members from powertrain, infotainment, core software, information technology really wanted to create a ubiquitous set of tools that we could really consent on and use and really came up with this mantra. Tools to be simple to use, powerful, easily integrated so that development teams can really deliver. So I told Tim, I said, okay, I'm in Clearcase. I got all my build environment embedded in this custom set. I need a new build environment. So we decided that my team I didn't have enough team members or people. I couldn't just stop production. I had to do something. So we discussed it. We said, well, you know what? We have this great internship programs and co-op students and early graduates on rotational programs. We need to leverage that GitHub knowledge that they've got developed in college. So we brought those team members on board. And so I'm a little bit of a history buff. So automotive history is one of my favorite things. And one of the big parts of the Ford Motor Company is when Henry Ford passed away. Henry Ford II took over. He was 28 years old when he took over Ford Motor Company. And so he didn't know how to run the company very well. He hired a whole bunch of young executives. And that's them there in 1946. And they were called the Whiz Kids. So I immediately started calling my young people Whiz Kids. And so thanks a lot to those guys that are out there. One of them's here today. And they really helped us to accelerate the delivery of our pipeline.
Yeah. So the first thing that we did was we pulled a powertrain application out of Clearcase, and we put it into GitHub in a monolithic repo or a mono repo. We knew going in that mono repo wasn't going to be up to the task of handling the complexity of our development patterns, but our goal was just to get the thing to build. Getting code out of Clearcase and into GitHub is a non-trivial task, and it challenged our group of whiz kids to write some custom scripts and some automation to help make that go a little smoother. So they spent 3 months just straight up hacking the make files to unwind all the hooks that Clearcase had in them from the current production build process. I'm a little bit different kind of a history buff. So the WizKids got us to a point where we had a solid demo that we could show to get buy-in. And so then we started to take a look at mono repo, and we needed to decide where do we put the complexity of of our software, right? So we started to look at submodules, but we decided that submodules kind of push the complexity down to the developer. So now that's one extra thing for them to manage, and we didn't want to do that. So that's when we started engaging with GitHub Services. So in early 2018, we talked to GitHub Services, and a couple months later, that's when Jared from GitHub joined our team to help us out with with our DevOps journey. So our sort of strategy, we kind of demoed our current build process where in Clearcase we have an app list file that kind of describes what the build looks like. Jared thought that we could get something similar going with Jenkins, and we started calling this concept the manifest. So the manifest is a YAML structure. It's readable by humans, machines, can be auto-generated. It's pretty cool. It didn't take us very long at all to get our mono repo building, and we liked it because we could cascade this definition file to various layers of the code base. So it was extensible, it was flexible, it could operate at many different layers of the architecture. So after we had that kind of figured out, we took a look at the components themselves, or the smallest unit of of the code base, and we're looking at like a one-to-one component to repo sort of relationship. So we have about 250 of those in our current context, and the build process for those is more or less the same. So we took advantage of Jenkins class libraries to abstract a lot of that out, which left us with simple 1 to 2 line Jenkins files. We really like this pattern because if we needed to update the build process for any reason, all we have to do is submit a pull request to one repository to change the class library, and all 250 components automatically consume that as soon as the PR merges. So the next part was how to spawn. How do we kick off these builds? How do we spawn them, right? So given again that all these 250 components are more or less the same from a build perspective, they all use the same tools, they all use the same process to build. Containers start to make a lot of sense. We could build one container, spawn it up multiple times, and get things to work that way.
And I really love that because I've got this data center of old servers. I'm constrained. I need a fully elastic, capable, containerized system.
Yeah, that's right. So our IT department runs a Kubernetes cluster internally as part of this Nextgen data center effort, and I co-manage what we call the software development ecosystem product. And our mantra in that team is kind of like, no matter what kind of software you're developing, there's a common set of tools that you kind of need in order to be productive. 2 of those tools, in our opinion, inside of our company are GitHub and Jenkins. And so, as part of our Jenkins work, we developed a pattern of running Jenkins inside of Kubernetes. We call it Jenkates. And using Jenkates, we took our powertrain build from 45 minutes in the current production context down to 10 minutes. And Jared actually thinks that we can get this down to 4.
Boy, that sounds awesome to me.
And what's really
fully
cool,
elastic, I can expand. I need the capacity.
He needs the capacity. And what's really cool is a couple of weeks ago, we actually took this whole thing and dropped it into Azure just to see if we could. And all it took was a 1-line code change.
And it was awesome.
So if you think about it, this whole concept really isn't all that different from the assembly line. So this is gonna, kind of bring us to the end of our talk, but I just wanted to share some lessons learned from our experience in implementing GitHub Enterprise inside of a 100-year-old company. So the first thing I would recommend is anticipate rapid growth. When we started, we had our use case that we were planning for was 100 devs in some small research department, right? And today our instance is pushing about 10,000 users out of our own data center.
On-prem.
On-prem, yep. So the next thing I would recommend is, obviously GitHub is the largest open source development platform on the planet. We learned that in the keynote. Nat thinks we're going to hit 100 million developers or something like that by 2025, which is crazy. And the power of launching something like GitHub Enterprise inside of your network is, it can facilitate an inner source model and really help to drive a culture change. inside of your company. So to that effect, I would take a real hard look about organizations and what kind of policies you want to put in place for allowing people to create organizations. This is something that GitHub beats me up all the time about, because we have, how many we got today?
Over 1,700. Tim.
Yeah, about 1,700 organizations. But since I'm up on stage and they're not, I'm going to hit back a little bit, because when we launched GitHub Enterprise, it didn't have the capability that it does today with like nested teams, and organizations was really the way to accomplish some of the security goals that we had internal to the company, right? But if I were launching it again today, there's a little checkbox in the management console that'll turn off the ability for people to create organizations, and then we'd put some sort of policies in place.
What if I want my own org though?
Then you got to have a good reason.
All right.
The next thing I would recommend is rate limits. Since GitHub Enterprise very quickly, kind of became business critical for us. Keeping it operational is, it's a big deal. For a company like Ford, if Tom's not able to produce software and brings an assembly line down, we're talking, what, $1 million an hour or something?
Millions of dollars, yep. $1 million a day sometimes, depending on the vehicle.
Yeah. So rate limits go a long way to helping us keep our users in check. And like what we've been finding is that we've got a lot of people that they want to do CI, but they don't necessarily know how to set it up. They don't know about webhook capability and stuff like that. So they just slam the API. Hey, has it changed? Has it changed? Has it changed? And
that's why I'm working with Tim, because we're going to be good actors.
Right. And so putting rate limits in place kind of it protects your infrastructure from going down. And the last thing that we do is we pipe all of our logs to Splunk, and we've got a lot of custom dashboards inside of Splunk. So if Tom starts banging away at the API 10,000 times an hour, then I'm going to know pretty much immediately, and I'm going to go tap him on the shoulder. So yeah, that's about it. And thanks for taking some time out of your day to come listen to us talk and hear our story.
Yeah, we really appreciate you all attending today. And we've got a lot of other knowledge we can talk to you about, and so we'll go from there.
Yeah, you're going to let me drive home, right?
I really need you to. With all the snow we got in Michigan, I'll let you drive. All right, thanks, everybody.
Thanks, guys.